Hello and welcome to another video. This is Cracking the Cryptic app Fog of War Pack puzzle number 22. It is an unnamed puzzle by Phistomefel. The rules are Fog of War. Correctly placed digits clear the fog around them. Classic. Every row, column, and box must have all numbers from 1 to 9 exactly once. Killer. The cells in each cage must sum up to the number in the top left corner of the cage, and numbers cannot be repeated inside the cage. Partial kropki. A white dot between two cells indicates the neighboring digits are consecutive. A black dot between two cells indicates that one of the digits is twice as big as the other digit. Not all possible dots are given. There is also a custom rule, which is nothing more than a hint really, saying that the number in each cage is always in the top left corner. Let us begin. We are given a vision of 3 cells, and we see that this is, in fact, the beginning of a cage that sums up to 17. We are going to color it with the color green. We also see that this is another cage, and since there is a double barrier between this and this, they are not the same cage. So we see that it goes downwards, so this is going to be our pink cage. We also see a little cage down here, but we don't know if it's its own thing or if it connects to the green cage yet. But we do see, because there's a barrier here, that it does not connect with the pink cage. Now, we draw attention to the fact that the pink cage does not have an indication of what the cells sum up to, meaning that this cell right here is not the top leftmost corner of this cage. So something else must be. Since it is the topmost cell, right, because it is in the top row of the grid, well, that means that it's not the leftmost cell. Therefore, one of these cells must be the top leftmost corner of the pink cage. Now, let's see how the pink cage could go in the shortest path to reach such a cage. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, this is the shortest path it could take, so this is the maximal length that it could possibly reach. Why? Because in the killer Sudoku, digits cannot be repeated inside the cage. So you can only use digits from 1 to 9 exactly once, leaving you with a cage that is at most 9 cells long. And since we traveled the shortest path upwards, that means that at most you can reach these 3 cells in a 9 cell long cage. So that means that one of these 3 cells must be the top leftmost corner of the cage. We don't know which one yet, but what we do know is that the pink cage must go downwards and somehow curl leftwards in order to reach it. Well, let's first assume that it goes downwards one more time and then goes to the left. Well, in such a case, it must immediately set its course straight and go to the left once, go to the left again, and then go upwards. Well, in such a case, you'll see that this length is exactly 9 cells long. So it would be its maximal length already. It does not actually matter if it goes down like this or if it goes down like this. So we can pick whichever side we want for the argument. The argument works the exact same. Let's assume that this is the path that it actually took. Well, if it took that path, you notice that the green cage is now completely separated from this thing right here. So this must be its own cage. And since it does not have an indication of what the cells sum up to, that means that its top leftmost cage is in fog of war. And the first 3 cell that could be its top leftmost part is in fact this cage right here. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. In order to be a part of that cage, it would need to be 11 cells long. But an 11 cells long cage needs to have some repeating digits, which contradicts the killer Sudoku rules. Therefore, this is not how it goes. And if we assume instead that, it didn't go down like this, but that it went to the left and then upwards, you're still having the same issue, because this is the first cell that can be a part of this cage. And again, it would have to be 11 cells long in order to connect. But that's a contradiction. So therefore, we conclude that the pink cage cannot go any further downwards, or else this thing will be too long. So it goes downwards only one time, and then it goes straight to the left because we're not allowed to go any more down, and we must eventually reach one of these three cells. Now it either goes down again or it goes left. Well, if it goes down, you run kinda into the same issue, because if you went down, now you have to go up, right? And now you still have to reach one of these cells, so what do, right? Did you just go straight upwards? Let's assume that you did. Well, again, now this thing must go around this way, and if you count, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is again 11 cells long. So let's assume that it didn't go straight upwards. But if it didn't go straight upwards, what did it do? If it went up and then zigzagged, that's only making it more difficult for the orange cell to loop around to a free cell that can be its top leftmost cell. So it cannot go down again. It must be going to the left. And now, does it go again one more time to the left, or does it go up? Let's assume that it goes to the left again. Well, look, if it does that, now this thing has to loop even further around to reach a top leftmost cell. And again, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cells long. It's still not allowed. So therefore, this cannot go more to the left, and it must therefore go upwards. And now, since it went upwards, we ask, what does it do next? Does it go to the left? Well, if it did, that means that this is, again, the top leftmost cell. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 also does not work. Therefore, it does not go here. It must continue upwards. Now, we don't know where else it snakes to. Maybe it goes to the left or not, but we're going to leave it for now. Now let's check this part. Since it's completely cut off from the green cage, that must mean that it is its own cage, right? So it goes down, and now let's check the shortest path it could take to reach a cell that could be its top leftmost cell. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That works, and that is indeed the maximal length that this cage can possibly be. So that means that if any of these cells were assumed to be its top leftmost cell, that would have to be more than 9 cages long in order to reach this cell, which would cause a contradiction. Therefore, this is the only place that works as its top leftmost cell. So this is the exact path that the orange cell must take. So let's first fill in every possible value of every square in the grid. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. We have a 17 cage, and that can only take numbers 9 and 8 because we see that it's bounded on all sides, so it's just 2 cells long. And that means that nowhere else in that cage or column can you have numbers 8 or 9. And now, since these two numbers must be consecutive, then this must be the number 7, because no other number can be consecutive with either 8 or 9. So that's a 7, meaning that this must be the 8, and so this is the number 9. And now, numbers 8 and 9 must show up somewhere on this pink cage, because the pink cage sums up to 42. And as you can see, with this many cells, it does not contain numbers 1 and 2, and it must contain numbers 8 and 9, and 8 and 9 can only show up in this segment of the pink line. Therefore, they cannot be anywhere else in that box. And now, since these two numbers must be consecutive, and this cannot be 7, 8, or a 9, then this cannot be an 8 or a 9 either, meaning that number 8 can only be here in this box, and the number 9 can only be up here in this box. All right. Now, This is a black kropki pair, so it cannot contain numbers 5, 7, or 9, because nothing doubles into these values, and the double of their value is over 9. So this cannot be a 5 or a 7. And now, since these two numbers must be consecutive, then this cannot be an 8 or a 9. So the only place for the 8 and 9 are in these two cells. So therefore, that is the actual 8-9 pair, because 8 and 9 must show up somewhere along the orange line, because it contains all numbers from 1 to 9. It's a 45 cage. Therefore, this cannot be 1, 2, 3, 4, 5, 6, or a 7. That is an 8-9. And since it's an 8-9 pair, you cannot have 8 or 9 anywhere else in that box or row. Now, number 7 has already showed up in this cage, so it cannot show anywhere else again. We asked the question, can a number 6 or 3 show up in this black kropki pair? Let's assume so. Let's assume that this is a free 6 in any configuration. Well, in that case, you would not have a 3 or a 6 in this row, which would make all 3 of these cells contain just numbers 4 and 5, which is a contradiction, because if this is a 4-5 pair, then this cell would be empty. Therefore, this cannot be 3 or 6. And now, since these 3 numbers must be consecutive, this cannot be a 7 or a 6. So can this possibly be the number 1? No, because it has 2 consecutive values, as you can see, and number 1 does not have 2 consecutive values. So this is either a 2 or a 4. So that means that these 2 numbers cannot contain the number 4, because the number 4 would force this number to be a 2, and they would not be consecutive. So they also can't be a 2, because that would force this to be a 4, making them not consecutive. All right. Now, let's just make sure we're not missing anything obvious. So a number 7 must show up somewhere on the orange line, and it can only show up here, meaning that it's nowhere else in the same row. All right, let's assume that this number is in fact the number 2. Well, if that's a 2, then since they're consecutive, this cannot be a number 5, so that's a 1-3 pair. So you would not have numbers 1, 2, or 3 anywhere else in this cage. So no number 1, 2, or 3. But since the number 2 is over here and it's not anywhere else in this box, well, it can only go up here, right? That's the only square for the number 2. But where does the number 1 go? Since that must be the number 2, there is no place left for the number 1 to go to, and therefore we are in contradiction. Therefore, that is not the number 2. It can only be the number 4. And since that's the number 4, and they're a black kropki pair, this must be the number 2. And since this is a triple of 3, 5, 6, then this must be the number 4. Since they are consecutive, this cannot be the number 1 here, so that's a 3, 5. So there cannot be 3 or 5 or 4 anywhere else on this in this cage. Now, number 4, let's just check everything. So these two are consecutive, right? So this cannot possibly be the number 3. And that gives you a 5, 6 pair. So we cannot have 5 or 6 anywhere else in this row. This is therefore the number 3, and this is the number 1. So now that gives us some vision over here. These two must be consecutive, and therefore this must be the number 7, because that's the only number that can be consecutive with 8 or 9, right? So that's a 7, and so this is an 8. And now the only place for the 7 on the orange line is right here. And this is a 9. And now we should be a bit careful. So let's just check everything, just to make sure we're not missing anything. Okay, so we are. Number 7 can only be here in this box, and so that's the number 7. One. So number 1 is either here or here, meaning that it cannot be anywhere else in that row. 1, 2. So number 2 must be somewhere up here, so it cannot be anywhere else in that column. All right, we are given a vision of something else. We are given a vision of this thing right here. And it's a cage that sums up to 11. It is at least 2 cells long. Let's assume that it is exactly 2 cells long. Well, if it's exactly 2 cells long, the only configuration that works here is 5 plus 6, right? So if it's a 9, there's no number 2. If it's a 6, it's a 5, 5, 6, 5, 6. For a 4, there's no number 7, and for a 3, there's no number 8. So 5, 6 is the only combination that works. But if that's a 5, 6, well, you would not have 5 or 6 up here, meaning that you would have number 2 in both of those cells, which is a contradiction. So therefore, this is not a 5, 6, and it must therefore be at least 3 cells long. Now, how could it reach number 11 if it is 3 cells long? Does it go down like this, or does it go down like this? And can it be 4 cells long? Let's check. So number 11, 4 cells long, yes, but it would need to have numbers 1, 2, 3, and 5. It can have them 1, 2, 3, and 5. That would work. But there is an issue here. And the issue comes from the fact that these two numbers are consecutive. So not just any configuration of numbers could work. So can a number 6 show up here? If a number 6 did show up, that would force the other number into being a 5, and that would basically cause a contradiction, because up here you would need to have number 2 in both sides. So number 6 cannot show up here. Number 9 also cannot show up there because they're consecutive and there's no 8. So can a number 3 show up? Well, 3 would force this other number into being a 4, which is in total a 7. So this thing would sum up to a 7. And then wherever it goes to, it would need to get the number 4 somehow, right? But that's a bit hard to explain, but if this is a 3, 4, it still needs to have plus 4 to reach the number 11. And it can only get that number 4 by either having numbers 1 and 3 again to sum up to a 4, or it could have number 4 directly, right? Because there's no other way to obtain the number 4. It's either 1 plus 3, or it is just the 4 itself. But it cannot have a 1 plus 3 anywhere here, because it already has the 3. So 1 plus 3 would mean that it's repeating the number 3. And it cannot have a 4 again either, because it already has a 4, and digits again cannot be repeated inside the cage. So a simpler way of explaining this is just going through all the possible configurations that have 4 cells. You see that it does not have any way of having a 3, 4, and when it comes to 3 cages, there is no configuration that works with a 3, 4. And therefore, this is not the number 3. And therefore, that's a 4, 5. They sum up to a 9, meaning that it needs a number 2 to make the 11, and the lower number doesn't work. So if this took the number 1 somehow, that would give you a 10, and then you would need another number 1 to make an 11, and that doesn't work. So this is the only place where it actually branches into the number 2, so this must be a part of it, and it contains the number 2. Okay. So that's a 4, 5, meaning that you cannot have a 4 or 5 anywhere else in that column. And now this cannot contain the number 1 because 2 isn't available. So that's a 5, 6 pair, meaning that you don't have 5 or 6 anywhere else. So that's a 2, and so that's a 6, and then this is a 2, 5, 6. A lot of new stuff opened up. Now, what else can we do? Well, we see a cage that sums up to 42. And this is the top leftmost part of the cage because it's the cell that has the indication of what the cells sum up to. So 42, that's a pretty big number. I'm assuming that it cannot be, you probably must need 7 or longer, right? So yeah, 7 cells works, 8 cells works, but a 9 obviously does not work. So it's either 7 or 8 cells long. So if we color it like this, 1, 2, 3, 4, 5, 6, 7, it must go up to at least 7 cells. We're gonna color it with the color red. Now, why does it go like this? Because again, it goes downwards, and this is the top leftmost part of it. So it can only stay on this lower cell, because if it went up anywhere, then that would be the top leftmost part and not this one. So it either goes up to here or it goes almost there, right? And since this is a free 9 pair, you cannot have a 3 or a 9 anywhere else in that box. So let's assume that it is 8 cells long, and immediately you see that if it was 8 cells long, then it would not contain the number 3, and it does contain it. So it cannot be 8, it must be exactly 7 cells long. And we see that it contains numbers from 3 to 9, so there is no number 1 or a number 2 here. So 1 and 2 must be somewhere here, and therefore they are nowhere else in that same box. So this is not the number 1 or the number 2. That gives you an 8 over here and a 1 over here. These two must be consecutive, so this cannot be a 7, and this cannot be a 1. Also cannot be a number 4 here. So that's a 3, 4 or a 5, 6. Okay. Now 4, 6, 7, 4, 6, 7, that's a triple, meaning that you cannot have number 4 here. And now the only place left for the number 4 in this box is right here. So that's a 4, and then that's a 5. So that's a 3, and these are consecutive, so that's the 4. So 4 and 5 must be somewhere on the red line, and the only place where they can be is right here. So they cannot be anywhere else in that same box. So this cannot be a 4 or 5, meaning that that's the 2. And now we have to be extra careful. So what about the number 3? Number 3 is here. 4 and 5. So 4 and 5 are somewhere there, meaning that they cannot be down here. So let's check everything. Number 1. So number 1 is either here or here, meaning that no matter the configuration, it cannot be anywhere inside these cells. And now number 1 is here or here, meaning that it cannot be anywhere in the selected cells in this box. So that's the number 1, number 2, number 3. So I probably forgot to do that, but 3 and 5 are a pair, so they cannot be anywhere else in that same column. That's a pair. So then this is the number 1, and that leaves this as the number 1. So that does reveal some new stuff. These two sum up to a 14, right? And so that must mean that they are either 5, 9 or a 6, 8. this cannot contain a 3 or a 2. It's a 5, 9, and since there is no 5 over here, this cannot be the 9. And 6, 8, 6, 8, that works on both ends. Now, what else do we have? Number 1, 2. So this must be the number 2 in this box. And then so this cannot be a number 6, because a 6 here forces this to be a 7, so this square would be empty. So in neither of these cells can you have a number 6. So that means that this or this is the number. No, actually this can also be a 6. Yeah, I have to be careful. So 6, well, I was at 2, then 3, 4, 5, 6, 7, 8, 9. So we kind of have to deal with this cage right here. It looks ugly because there's like a bug, but yeah, that's a cage that sums up to 16. And there is also a cage up here. I don't know if you see it, but that's a border of a cage that extends like this. We're gonna color it as green. And this is a cage that sums to 16, so let's just color it as pink. We don't know how long it is, but we do know that it is not exactly 2 cells long. So let's show why. The only way it can be 2 cells long is if it's a 7, 9. But then you would not have 7 or 9 anywhere up here, which would cause an immediate contradiction because 6, 8 would have to be in 3 cells. So it has to be bigger than just 2 cells. It has to be at least 3 cells long. And it cannot go to the left directly because there's a barrier. And this is the top leftmost corner, so it doesn't go upwards anytime, right? So now number 6 has to be somewhere down here as well, right? Inside this red line. And same with number 7. So 6 and 7 have to be somewhere on this line. So you cannot have 6 or a 7 anywhere there. Okay, so that makes things slightly more clear. But let's keep going. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the annoying thing, we do know that this is not a part of the 16, right? So 16 is at least 3 and at most 4 cells long. So let's start assuming the values that this thing could have. Can this be a 9? Well, if that's a 9, you could at most have these bottom ones being, if it was 2 cells long, you could have this be a 3 and 2, which is a 5, which would sum up to 14. And at most, if you include all of them, they could sum up to 15, which is not 16. So this cannot be the number 9. So what about the number 8? 8 doesn't help you. So 8 is too high to sum up to a 9, right? You cannot make use of the number 9. So since you cannot make use of the number 9, you need to only use 1, 2, and 3. 3 and 2 by itself is too small to reach 16, and 1, 2, and 3 together are 6 plus 8 is it's just 14. So that's not 16 either. You cannot reach 16. So number 8 here also doesn't work. 7 also cannot make use of the 9 because 9 and 7 are directly equal to 16, but this is at least, as we said, 3 cells long, which would be higher than 16. And if you're not making use of the 9, then this is at most 7 plus these 3 would be 7 plus 6, 13. So this cannot be a 7. What about a 6? Well, obviously, 6 plus 6 is 12. So essentially, the digits are low enough now that you know that you must make use of the number 9 here somehow, right? Because a high number right here, even if it was a 9, it does not work, because then a 9 is not down here, and at most these 3 sum up to 6. So at most, if a 9 is here, that's 15. If it's any lower than that, you know, eventually you have to reach a number low enough that you actually make use of this number 9 down here somewhere. So since a number 9 must be down here somewhere to be made use of to make the 16, that must mean that number 9 is nowhere here. And that gives you number 3 here, and then a number 9 here, and the number 8 here, and then that's a 7, so that's a 6, 7, 6, 9, 8, 6. So that cleaned things up quite a lot. So let's just refocus on this just for now. Apparently, let's find a configuration that does work. So 9 plus 5 is 14 plus 2. That's directly 16. That works. Or 9 plus 4 is 13 plus 2 plus 1 could be 16. But a number 3 here does not work. So this is 4, 5, and then this is 1 to 9. So there's two configurations, both the 4 and the 5 work, and they both make use of the 9. And now, let's take a look at this cage. We see that this is the top leftmost cell. They sum up to 12, and they go to the left, right? So this cannot possibly contain the number 9 anywhere, because the other lowest values here are 2 and 3. Can it contain a number 8 anywhere? No, again, because the other lowest values are 2 and 3. And now let's just quickly go through all the digits, because I think some new stuff opened up. So 1, oh, there's a 5 here, for example. There's a 6 here, and then there's a 1, a 3, and a 1. So stuff did open up. And we have a 3, 4, 5 triple, meaning that this must be the 9. And so number 9 is here. So let's just, so we have a 2, 7, 2, 7, that gives you the 9, meaning that this must be the 3 to make a 12. And now 1, 2, 3, 4, 5, 6, 7, 8, and 9. If I didn't miss anything, I suppose that we now have to focus our attention on this cage that just opened up. So this also sums up to 16. And it can either be, it is at least, as we can see, it's at least 2 cells long. But can this be directly 9, 7? No, because number 9 isn't there. So it must be 3 cells long, but we don't know the direction that it takes. Maybe it's like this, or maybe it's like this. Can it contain the number? Can it contain the number 6? Or maybe should we start with the, let's start with the 6. It doesn't matter which one we start with. So if that's a 6, then these numbers, the other numbers you have, must somehow give you the number 10 to make the 16, right? These two obviously cannot give you a 10, or these two directly, so you would have to make use of all 3 numbers that are in fog. So you would have a 16 that's 4 cells long. But how would you do that? Well, one way would be to have this be a 4, 5, and this would be the number 1. So this would be a 4, 5, and then this would be the number 1. So now it sums up to 16. But in such a case, you would be in a contradiction, because if that's a 4, 5 pair, then this cell would be empty. So that doesn't work. What about another way? Well, another way would be to have 3, nope. So if this is a 3, 4, that gives you 7, but then you would not have the number 3 here to get to 10, so that doesn't work. But a 3, 5 does work, so if that's a 3, 5, oops. So if that's a 3, 5, that sums up to an 8, and then this could sum up to 2, giving you the 16. But now you would not have a 5 or a 2. So this thing could only sum up to 14, which is a contradiction. So basically, if the 6 is here, there's just no way to get the number 16 in that cage, so this cannot be a 6. Let's see if maybe that directly gives us something. No. Let's assume now that it is in fact a 7. Well, if that's a 7, now we need to sum up to number 9 using these cells somehow. Again, if they just directly use, if we directly use 4 and 5 here, that's a contradiction with the fact that 4 or 5 must be here, so we can't do that. Can we use 5 and 3 over here, and then a number 1 over here? Yeah, we can, but let's see what happens. If you do that, then this does not have the number 5 or the number 1. So that's a 2, 9, which is 11 plus 4. That would be at most 15, because this is the 16 cage. So that doesn't work. So if that's not 3, 5, that only leaves you with a 3 and 4. And then this must be the 2. So together they make a 16. But now this would not contain a 4, oops, a 4 or a 2. So this thing would sum up to 15 and not to 16. Again, causing a contradiction. So number 7 cannot show up here because no configuration gives you a 16 without ruining this thing. And therefore, this must be the 8. And now we see that it is in fact exactly 3 cells long, 4 cells long. And since that is 4 cells long, that must mean that this is not the number 4, because if this was a number 4, then if you remember, this was 4 plus 9 plus 1, 2, 3, plus 1 and 2, right? 4, 9, 1, 2. But because you don't have this cell anymore available, it's a part of this other cage, then this must be the number 5, and then this is a 9, and then this is the 2. Or, well, the other way around, right? We don't know which one is the 9 and which one is the 2. But this cannot be a 2. And so this is a 7. Now, this cannot be a number 1 because these two are consecutive. And I'm expecting some stuff to have opened up. So let's just go through the digits. Yeah, so this is the number 1. And so this is a number 1. Let's check the number 2. Well, yeah, actually, number 2 is here or here, meaning that it cannot be anywhere up there. And so the only square for it is right here. If this was a 3, this would have to be a 5 and they would not be consecutive. And if this was a 5, then this would be a 3 and they would not be consecutive, so this cannot be a 5 either. And now we have a 4, 6 pair, meaning that you don't have 4 or 6 anywhere else. All right, what about the number 3? Nothing here. What about the number 4? Let's check the number 5. All right, 6. So number 6 is either here or here, meaning that it cannot be anywhere here. And so that is the 4. So that's a 5, and then that's a 6, that's an 8, and this is 3, 6, 5, 5, 4, 9, 8. Then this is 3, and that's a 4, that's a 5, 3. Click. Okay, that's a 5, and then this is 7, 6, 2, 7, and the puzzle looks pretty complete. This is 5, 4, 2, and 4. Thank you guys for watching, and see you in the next one.